The objective of this video is to practice static equilibrium problems. To determine the force a person's triceps can exert, a doctor uses a procedure where the patient pushes down with the palm of his hand on a force meter. Given that the weight of the lower arm is mg equals 15.6 newtons, and that the force meter reads F equals 89 newtons, what is the Ft exerted vertically upward by the triceps? This diagram depicts the situation shown in the problem. Pay special attention to the distances between the muscles and the direction of the different forces. The first step to solve this problem is to create a free body diagram. This will make it much easier to solve the problem. The diagram shown before showed three forces: the force of the tricep, the force of gravity, and a normal force exerted by the force meter. What we did was we created a free body diagram based around the arm. Imagine that the box we drew is the arm. The force of the tricep pushes up, the force of gravity pushes down, and the force of the push itself pushes downward. Also, there's another force we added to the diagram. The force of the joint in the arm pushes downward. The force of the joint counteracts the force of the tricep. This is important to the problem because it adds another variable. The next step to solve this problem is to use torque. First, you must decide on a pivot point. We decided to use the tricep. Since the tricep is now the pivot point, the torque of the tricep is equal to 0 because the radius is 0. Remember that torque is equal to the force times the radius. Now, use the torque is equal to 0. That's never going to change in any equilibrium problem you do. In this case, the torque of the joint is positive, while the torque of gravity and the torque of the push are negative. So, the torque of the joint minus the torque of gravity minus the torque of the push is equal to 0. To simplify this, the torque of the joint is equal to the torque of gravity plus the torque of the push. Now, using the equation for torque and the information you have, start plugging in numbers, and if you solve this problem correctly, you should get the force of the joint is equal to 1,244 newtons. To solve for the force of the tricep, you can use the sum of the forces is equal to 0. Using your free body diagram, decide which forces are positive and which forces are negative. In this case, the force of the tricep is the only positive force. To use the sum of the forces in this case, the force of the tricep minus the force of the joint minus the force of gravity minus the force of the push is equal to 0. To simplify this, the force of the tricep is equal to the force of the joint plus the force of gravity plus the force of the push. Start plugging in numbers and solve. If you get this correct, you should get the force of the tricep is equal to 1,349 newtons.